Hello and welcome back, everybody. Here's our next project on the bench, and you can see it's a pretty interesting little amp. It's a Yamaha CA-810, and it's got a few unique features and some pretty cool things in the design, so I thought this would make a good video. And the owner sent it in for a full restoration. So we're going to go over it and try to bring it back to its former glory. And I have not had it apart. I haven't looked at anything. When it showed up, it was missing two of the knobs. The input selector, which looks like this one, and you can see this one's ready to fall off. It's real loose. And the volume knob. Now, they were missing. And apparently, the owner is looking to purchase a set of these. If any of you out there have a set of these or have an old parts amp or know of a source to replace these two knobs, the owner would really appreciate if you'd share that information. You can go ahead and you can either message me or email me. My contact info's on all of my videos, and I'll make sure he knows that and you guys can work something out. But just wanted to let everybody know that. Anyways, I haven't even really looked up all the specs on this amp, but I'm assuming it's somewhere in the line of 50 watts per channel. A lot of times you can tell that if an amp has power meters, you can see where they have the 0 dB and it lines up with 50 watts into 8 ohms. And also, usually the peak of the meter is usually set to about double the RMS clean output of the amp. So for instance, a 50 watt amplifier will usually show you full scale at 100 watts. That's kind of what they do. A lot of people mistakenly will look at that and they'll say it's a 100 watt per channel amplifier, and actually it's not. It's 50 watts, and that's for allow the meter to deflect for peaks. When this thing's really cranking up, you can see the peak will actually jump up to that level. So anyways, this is going to be, I think this is going to be a lot of fun. So let's take it apart and see what we've got. Again, like I said, I never power these up without first giving them a once-over, because you never know, rattling around in the shipping and all that. You could have a perfectly working amp, and by the time it gets here, something comes loose or something, and you don't want to cause any shorts. So let's take it apart and do our initial scan. Okay, taking a look. You know, your typical crud and dirt that you always see on this vintage of equipment. I do notice that there's a screw missing up here, so it looks like this was taken apart most likely at some time in its life. That, you know, somebody cleaned the contacts or something, I would imagine, and the screw got lost. Kind of cool how they do the heat sink. The actual sides of the chassis, if you see the side, the chassis side is actually your heat sink. So you have this aluminum plate, goes all the way across, and then you have this aluminum fin, you know, that attaches to the outside. And this actually, these become part of the heat sink, but they also cover the transistors. And this uses TO3 style transistors that you can possibly see down in there. I don't know, can you see them? Again, great big power transformer. I like to see that. So there's a lot of energy there. And if you look at this, 12,000 microfarad, which is kind of loose. This one's loose. This one here feels like the solder joint is broken. Need to resolder that. But 12,000 microfarads at 58 volts, so that's an odd voltage. So we'll check those out. They may or may not need replacing, but with 12,000 microfarads, these should have a lot of reserve for big transients and big peaks, which is great. I get a lot of questions about the filter caps and about capacitors in general, and when you replace the caps in any electronic device, you're always best to retain the same capacitance and voltage as the original. Now the one exception to that is things that were built in earlier days, our AC mains was a little bit different. It was anywhere from 110 to 115 volts AC. Current average voltage across the country now, at least here in the States, is 120, 125. My voltage here at my bench, I can fluctuate up. I've seen it as high as 126 volts. So what ends up happening is the transformer just basically it transforms at a ratio. So if you had, if it was originally designed to put out a certain voltage at 115 volts in, and now you're putting 125 volts in, you are going to get a little bit higher voltage out. So, some of your non-regulated voltages, only the non-regulated ones, may be a little bit higher. So in those instances, I may go the next step up in voltage on a capacitor. It doesn't hurt to go a little bit higher voltage on the caps as long as you don't go crazy. You want the caps to stay formed and everything. And again, I don't know the science behind that. I don't even know how much of that is a concern or not, but I try to keep them the same. Now, with the main filter caps, they serve two purposes, and a little bit different than just what the rest of the amp is. These obviously add filtration to your rectified voltage. So you have your rectified DC, which has 100% ripple without any capacitor. So this will remove the ripple. And if you look at my linear power supply video that I did, I explain how a capacitor removes the ripple, and we also showed how increasing the capacitance gives diminishing returns on the amount of ripple. So I can go way up in the capacitance and it really doesn't make that big of a difference in the ripple voltage. So why do you see such humongous capacitors as the main filters if really they could get away with a cheaper cap, that's lower capacitance and have virtually the same ripple, very similar? Because remember, the current on this, if you do the math, you don't always need this high of a capacitance. Well, the reason is these don't just act as a ripple filter, but they also act as kind of a reserve. When you put a transient, in other words, you have an instantaneous peak, like a heavy bass note or something, this transformer has reactance to it. The magnetic storage capability of the core and everything, and again, a whole lot to a transformer theory, how it works. You could have a instantaneous sag in that voltage, and that sag will carry off to your output transistors, and it will affect the output to the speakers. Technically, it could create distortion or flat topping your waveform or whatever. So that's where these come in. By having a larger capacity, these will maintain that power, that voltage under that transient longer than just your transformer will, until the transformer can kind of catch up to it. So to a degree, having a larger reserve capacity in your caps makes sense. It doesn't make mathematical sense with respect to just ripple on a continuous current, but for instantaneous peaks, that's why you have a bigger capacitor. Now, I've seen some people cut holes in the top of their cases and put these big, Coke can capacitors in these little amps. That really makes absolutely no sense because of the load that they're driving, and even with the peaks, you're never going to do that. But so there's still limitations, diminishing returns once again. But that's why you see these big caps like this. So and one telltale sign of a well-built amp is they do have nice, heavy, overrated filter caps in the output section to maintain during heavy bass notes and transients like that it maintains a nice smooth voltage on your output transistors. So there you go, little talk on caps. But other than that, we need to get some schematics out and kind of plot our course of action here, and we'll start the process. So to get this apart, all you do is, you can see these three shafts, they just kind of plug in there. And there's three of these little C-clips, and they clip on the inside here, on the opposite side of the faceplate to keep them from pushing forward. Once you take those out, you can pull them out of the sockets. There's 4 screws in the rear holding a little flange, and then this whole module just slides right out. Now we have the your input signal or your output signals from your input select board, and we'll need to desolder those, and then you have your plus and minus power there that'll come out, and then the whole thing's ready to come out. So that's all we got to do. Okay, we got the input module out of the way, and obviously very cruddy. And that's to be expected. You see that in these old things all the time. Really, I don't see any discolored or burned components, so that's a good sign. However, as always with this vintage of equipment, no matter who the manufacturer is, we have that horrible glue that just completely eats everything away. Now if I get in here close enough, I don't know if the camera will stay focused, but if I get in there close, you can see how it's just eating everything away. I mean, and the problem that happens a lot of times is if that glue gets on the pins of those transistors, it will start to corrode the pins, and the corrosion will go clear up the pin, and it'll go clear inside the transistor, and it will cause damage on the transistor, and eventually the transistor will get noisy, and eventually it will fail. Now on the transistors that don't have glue around them, they last a very, very long time. There's really no reason to ever mess with them unless they fail. You know, so when you're not around the glue, like over here, this section, you really don't have that glue anywhere because there's no big components that they wanted to fasten down. So typically you won't have a problem with these transistors, but you will see it a lot of times. There's another one. If we get down in here, you could see all around in there, that all needs cleaned out. So we'll remove those components and clean, and then put them back in if they're good, or replace them if they, if they show any signs that they need replaced. But that's kind of what you run into on these. A lot of the restoration work on these old stereos is just elbow grease, a lot of cleaning and so forth. That's part of it, because they're crusty. The other thing is, whenever they use this plastic tubing, it's not heat shrink, it's just like a plastic tubing, and some of the plastic that they used on the wire insulation, plastic has oil in it, and sometimes the oil will separate from the plastic, and I'm not a plastics engineer, but it'll make it kind of sticky and gross, and then dust will just attract to it, and it'll get really dirty and dusty, and you can see that has happened on this, and that's normal. That's what happens with this kind of plastic coating, whatever it is, PVC or whatever. I'm not sure the composition, but I just know it's the old 70s plastic that does that. So anyways, there you go. We're going to start flip this thing up and look at the underneath. This capacitor here is literally, you can just flap it in the breeze. I'm wondering if the solder joint is just completely cracked off underneath or what. But even the glue has come loose that they used to glue this down. This one's pretty tight. I mean, I can move it, but it's tight. You can feel it doesn't have any kind of play. This one is just flopping around. I don't know if it's, we'll look. So let's get it flipped up on its side here and take the bottom off and take a look. Okay, we have the bottom off, and strangely enough, if you look at these solder joints, they are absolutely tight and absolutely perfect. And as I wiggle that capacitor, I'm reaching around, it doesn't move at all. So I'm wondering if either A, the cap's just not properly tightly seated to the board, and it's just wiggling on the contacts, or if if the contacts are actually starting to break loose. I don't know. So we'll remove those caps, and anyways, they're going to need fully tested and everything anyways. And you can see all these jumpers. Anytime you see these kind of jumpers here and the ones up here, even if they look good, it always helps to put a little bit of flux on them, some RA flux, and kind of reflow them and then clean them off, just to ensure that they're not cracked, because they're notorious for cracking. So we'll do that. Although these ones are so fixed that they don't really get a lot of stress, so I wouldn't expect them to be too bad, but we still check them anyways. So the bottom, other than that, is pretty uneventful. There's no components down here. Everything's on the top on these amps. So we'll start our cleaning. Okay, I have the amp dusted out, cleaned out, inspected. Didn't see anything that looked too bad. Put it back together now, and we just brought it up very slowly on a variac. And right now at full power, losing my voice here, it's drawing about 250 milliamps at idle, which is okay. I'm looking at the plus and minus 25 volts that's used, the regulated supply for the input board and so forth. And right now I'm on the positive 25 volts, and as you can see on the meter, we got 25.76, and the negative 25 is also good. I checked that, so those are good. Now we kind of have to flip it over to actually look at the main DC rail for the outputs, and that's gonna, I'm kind of curious to see with that loose capacitor what that one side looks like. It might have some noise on it or something, I don't know, but we're going to check that out. I'm starting to get the feeling that possibly all that it is that the cap is just not seated on the board properly, and it's kind of wobbling around on the terminals because the glue has come loose, but we'll see. Alright, we're connected up to the positive rail power supply, which is that capacitor that was kind of loose, and just looking at the DC voltage, it's very solid. And let's see here if we can, oh, wait a second. Okay, a little bit better. Hit the wrong button on the camera here. So we have our 47 volts, and if we just switch over to AC, just to check the ripple, and this doesn't show as much as an oscilloscope would for ripple, but at least we know that there is a connection there. And very low ripple, you know, on 20 millivolts or less, which on an unregulated supply, that's perfect. So I just think the cap's not properly seated on the board, and that's all there is to it. So we'll remount that, and I think things will be okay. We'll pull the caps anyways to test them. So the protect relay came in, so that's good. There's no shorts or anything that I can see right now. We're not drawing any crazy idle current. So I think I'm going to connect this up and just see how it works as it is. And we'll go from there. Alright, the amp's back together. It's connected to a dummy load. And we have our signal generator connected, as we always do. And this amplifier is exhibiting a really strange problem. So let me show you what it's doing. So first thing, if we have it connected, I tried this on multiple inputs. I started with the auxiliary input, now I'm on the tuner input. They're all the same line level, just different inputs. And I have everything set pretty much the way you would normally listen to the amp. And if you look over here at the screen, as I turn the volume up, and let me, you can see everything looks good so far. It comes up, and by the way, I looked at the specs. This amp is supposed to be rated at about 65 watts per channel instead of 50, so pretty healthy. And everything looks pretty good. They're not perfectly balanced, but you know. But if I put a little bit of signal in here, and let me change the scale here for a minute so that I don't have to crank the volume so hard. So we turn it up, and you can see we have right and left channels. If I turn the balance knob, so here's your volume, here's the balance, right and left. I should be able to make the one channel go off and the other go on, but if I turn it to the left channel, they both go off. If I turn it to the right channel, they both go off. Now, if I turn off my signal generator on one channel, they both go off. If I turn the other channel off, it makes no difference. So what's happening is everything is going through one channel and the other channel is pretty much not working. Now, I did look at the schematic, and this is a very typical amplifier design. There's really nothing super special about it. It does use a common ground. That's something you always have to watch on an amplifier, is that if they have common ground versus isolated grounds. If the ground negative lead is isolated between the two channels, you have to watch when you're using your dummy load that you're not tying the two grounds together, because that'll cause a problem. But that's not the case with this amp. It's a very common design. So there's something really fishy going on with inside this amp. It's clean. It's putting out all kinds of power. Actually, I clocked it into 8 ohms at 92 watts per channel. So lots of power, but for some reason, the input. So what we're going to do now is we're going to separate the preamp from the amp. We're going to take the little jumpers off and see if the problem is related to the amplifier or to the preamp section. So let's do that. Okay, the total weirdness continues. So now I'm looking at the preamp output on this scope, and I have my volume turned all up right now. I have a 100 millivolt RMS signal going into the auxiliary input, and if I rotate once again, if I rotate the balance knob, left channel, right channel, center. So that's the one strange thing. Now here's the other thing. If I turn off channel 2, both channels stay on. If I turn off, now I got them both on again. If I turn channel 1 off, boom, it goes off. You lose both channels at once. So there is something really strange going on inside this amp. Not only by separating the preamp and the main out, the main in and preamp out, we're separating the two sections of the amplifier, but somehow the two channels are not working properly, both on the preamp and the main amp. Now, I need to really look at this because I want to make sure that don't have a PEBCAC error. You know what that is, on computers, PEBCAC stands for problem exists between computer and chair, and I don't know, that might be what we have here. So let's see if we can figure out what's going on here. I've never seen anything like this. Okay, it's fixed. We found the problem. Boy, was it a weird one. So first of all, I'm plugged directly into the main amp input now, as I was before. There's one channel. There's the other channel. And there's both channels. Now they're separated. Now let's talk about what happened. Okay, I am now zoomed in on the input jacks, and you can see my input signals. And you can see how both of these are put together. And again, this must have been like this forever. I mean, I don't know. But if you look, this is going to the top connector, and this one here is going to the bottom connector, and then this center one is a common ground, you know, the ground shield of the RCA connectors together. So you can see, if you look at this, it's bent all the way down, and you can see that this jack here is pushed ever so slightly. This little, see how this metal tab is recessed on the top here? You can see it doesn't protrude. But if you look at, I don't know if I can get in close enough, but if you look at this, you can just see right here, see that little shiny spot right there? This is pushed out ever so slightly. So from the, and the funny thing is, this is not a jack that anybody ever uses. And it was actually just barely touching right here, and you really cannot bend this out. I mean, I have it bent out right now just a little bit. I had to kind of pry on it, but I didn't want to pull too hard. But really, that's a terrible design. They should have put a little piece of heat shrink or spaghetti tubing over that. This one also has some resistance, and if you kind of push on it, you can see it's barely touching the bottom as well. So both sides were a little tiny bit, and I don't know if that was like that from the factory or if this has been like this. And I don't know, but what we're going to do is we're going to remove this jack completely from the board. We're going to slide on a piece of heat shrink so that that doesn't happen again, and we're going to put it back in. And who knows, this might have been like this for a very long time, because you really, unless you really listened, you probably, or turned the balance knob, you probably wouldn't have even noticed this. So strange little problems. So let's fix it. Take a look at that, and you can just see how that just touches right in there. Same thing on this side. You can see. So we're going to just slide some heat shrink right over those, and that'll prevent that from ever happening again. I've never seen anything like that. Really odd. And the thing is, I could see where if you pushed on the back of this, and it would push against this in like that, it could shove those back. So there's a lot of different scenarios how that could have happened. But that is really odd. That's the first time I've ever seen something like that. Really weird. All right, much better. And even to get in there, I had to remove these two larger sized capacitors, 100 microfarad, 35 volts. And that gave me just the opportunity to start the recap with the first two caps. So we got our new KT series 105 degree audio grade caps with 100 microfarad, 35 volts. So that's all set, and I'm going to put everything back together, and we're going to see if we fix the problem. All right, so I have this switchboard out and the input select, and I checked all of these, and what I noticed is that all of them are very well recessed down inside there. They don't protrude out, so like if this is down here, it's not going to touch them. So I kind of have a theory now of what may have happened, and that is on the main amp in, preamp out section, those have those little horseshoe jumpers. And when you have an RCA connector like this, it actually will stop. In other words, it can only go down in there so far, and then it'll bottom out on the connector. Whereas those little horseshoes don't have that this outer part to make it stop. So what's happening is if you push too hard on those, it'll actually pop these little inserts right out. So I think what may have happened is when I received this amplifier, the circumference of it was wrapped with bubble wrap, but the front and back did not have any wrapping on it, and it was kind of loosely packed in the box, so it could kind of flop around. What may have happened is it may have hit right on those two jumpers, and they may have pushed in, which forced those out. Now, that would explain how it got like that, and the owner never said anything about it, or that may have been like that for a while, and you know, it just, the owner thought it was something else or whatever. I'm not sure, but I will email and ask him if he noticed any kind of strange problems like that. But anyways, we fixed it, and it's something to be aware of. I guess I never thought of that, but maybe a good thing to think about is when we ship these amps, maybe pull those little jumpers out or cover them with something so they can't hit on anything when you're packing it to ship it. So there you go. So while I had this out, I just went ahead and recapped it, so it's all set to go. So I'm just going to put it back together, and then we're going to test out and make sure that it's working, and then we'll proceed on with the rest of the recap and so forth. Okay, we have the amp connected back up to the signal generator and to the dummy load, and have a signal feeding into right and left. And when we turn the volume up, you can see we have a sine wave, and if I turn right channel, left channel, she's all fixed. So that's what it was. That's all that caused all that, was that shorted RCA jack. Okay, so now we're going to pull the input module back out, and we're going to now proceed with doing our recap. Now that we know everything works, everything seems to be working just fine. Well, we're slowly going through all of this and recapping it and cleaning all of the corrosive glue. Every one of these little transistors had to come out and get checked and cleaned and make sure they weren't corroded or no problems. So far, they've all been perfect. It looks like they only put the glue on the backs of the aluminum heat sinks, and that's what caused it to, it really messed up some things. Got some corrosion, so these little cleaning pens, they have like these real fine fiber bristles, and they work really well for taking off any kind of tarnish or anything on there, and it'll take it right down to shiny metal. And you clean that off and then put a little bit of conformal coating over it and be good forever. So I went to check the relay, and this one's really bad. It needed replaced. You can see just how charred that is. It's like all gray and charred and messed up. This is one of those ones where the actual coating, the plating on the contacts has actually corroded. So if you clean it, it's just going to corrode immediately right away. So we're going to replace it with this, which is an industrial. It's a very high quality relay. The main difference is they both have the same pin out, but the difference is this one has PC mount pins. This one has little kind of like for a socket. So you have to, just a tiny little bit, you have to open up the holes a little bit bigger. As you can see, they're just slightly different in size. So I've done that already, and I've got this all set to go up here, and we're going to get it mounted in there, and they'll have a nice new relay. Okay, we're all recapped, and we're ready to do another test on the amplifier. And if everything's good, we're going to do the alignment, which is pretty simple on this. We're just going to do the bias and balance adjust. And I remounted these caps. I tested them, and man, they test like brand new capacitors. I mean, they have extraordinarily low leakage, and their capacitance is dead on. Even tested it on my Sencor Z meter and the LC53. And it's perfect. So I remounted them, and I spent more time cleaning this kind of glue stuff off of that board than I did recapping it. Meticulous. You have to go in there and just pick every little piece off. This stuff, now this was still pliable. When it's pliable like this, it's usually not conductive, but after it dries, it starts to eat away at any metal, so it'll corrode everything. It'll corrode the leads of your transistors. It'll corrode your caps until the capacitors actually will short out. All the little jumper wires that are soldered on the board, it'll corrode those off. If there's any corrosion on any of the wires, again, I showed you this little cleaning brush. You need to use it to clean any corrosion off, and use alcohol, wipe everything down with little cotton swabs and things. But sometimes you need to reapply some sort of adhesive because you need that mechanical security, you know, to hold something, you know, that mechanical stabilization. And as you can see, these capacitors had come loose because the glue was no longer holding, and that's what was causing them to wobble around in there, which is a bad thing because that could actually cause the capacitors to break off, you know, either break the traces on the back of the board or break the leads off the caps. So you do need some sort of an adhesive, and here's what I use. And I just took a bead of it and put it all around the bottom circumference of the cap, and then pushed it down in and soldered it tight to the board. Left it dry for 24 hours, and it's good. But I use silicone, but not just any. Let me show you what kind I use. This can be purchased at any kind of your local home stores here in the States anyways. Lowe's, Home Depot, Walmart, all these places sell them. But you need the silicone 2. Now GE is this is one of the ones that I know works. There's other brands that make it as well. This is the one I know for a fact is good. The reason that you got to watch, just because it says silicone, it's not the silicone that's the problem. It's the agents that make it dry and so forth, the chemicals they put in it. There are ones that are acidic, and those are the ones that are highly corrosive to metal. They'll do the same thing that this brown stuff does. If you use this, it is non-corrosive, and it works really well. You put this on, it dries very well, it holds everything together, and it is non-corrosive, so you never have to worry about that. So just a little tip there. So we have it all done, everything's recapped, and we're going to start on the process of doing the alignment. Right, I thought I'd stop here for a second to show you all something that looked kind of might be a little bit interesting, and that is the panel lamp system for this. Is really cool. So you have this backer board which has your dropping resistors, and basically all they're doing is they're connecting between the positive and negative 36 volts. So you actually have about 72 volts going across there. And you have 4 light bulbs, and they're little grain of wheat bulbs that look, they're all burned out on this one, look kind of like that. They're just tiny, and they're in these little rubber holders. The wires poke through and just kind of fold around and stick out the front there, and then they push over these little pins on this little board. You can see how this one's on. You just pull it off. See the pins, the wires folded around in there, and then they're all wired in series. So if you look at the schematic here, you see here, I'm looking through the camera. Right here, you can see the 4 bulbs right here, and they're all in series. And you have your positive 36 and your negative 36 right there, B plus, B minus. And then it goes through these dropping resistors. You have this 560 ohm here, and then you have this resistor here, which is kind of like shunting across the resistors as well, or across the bulbs through this little diode. And so essentially this should be really easy to adjust this resistor a little bit and replace these with LEDs as long as we put them in the correct polarity. And then they have this little metal, or this little plastic lens, which gives it like a blue tint, and it is coupled to this right here, like this, to this diffuser acrylic, and then that goes through a little slot down inside here, under here, and positions right over top of the meters to spread the light evenly across the meters. So these meters, when they're working properly, probably had a really nice looking blue glow to them. So we're going to try to restore that with some LEDs, and we may have to do a little math and figure out the dropping resistor so we can change it, and then we should have our panel lamps back. Alright, and here is our lights. Very nice. And there we go. All right, now for the output transistors. So to get these off is really easy. All we got to do is just loosen 4 screws on each one of these things. The cover is keyed and it just lifts off. And you can see they just couple it with some grease there. And it's just a modular heatsink. And there's your 2 transistors for your outputs. And they're a little bit grungy and cruddy, but we're going to get those swapped out and cleaned off, all new grease. And we should be like new. Okay, we got the transistors swapped out, the outputs, and to my surprise, they had 2 different types of transistors, and this was all stock, factory. I mean, you could tell from the heatsink grease and from everything that this doesn't look like it's ever been taken apart for any of that. But if you look on the left channel, you had the Toshiba transistors, the 2SD425 and the 2SB555s. And on the left channel, we had the NEC transistors, and they're 2SB600 and a 2SD555. And also, not that it really matters because of the way the feedback circuit is designed, the way that the output section on these amplifiers are designed, it doesn't matter. But they actually have a lot different gain characteristics and so forth. Again, doesn't matter, they would work perfect. But anyhow, I thought that was kind of interesting. And I mean, you could see they're really different. I mean, you can even see how they just look different. But not a big deal. They all tested out perfect. There's nothing wrong with them. But I replaced them with a couple of MJ15005 and MJ15003 and MJ15004 transistors, which are nice heavy-duty transistors. We won't have any problems with them. Those will last a lifetime for them in there. And yeah, I just thought that was kind of interesting that they did that. But I guess they used what they had. At least they used the same manufacturer on each side. And quite honestly, a lot of times the transistors work somewhat like tubes. You know how any of you that work with vacuum tubes, the 6550 tube and the KT88 tubes are very similar power-wise and performance-wise. And, you know, you may be able to swap those out in an amp and they'll bias right up and work pretty much the same. Same thing with the 5881s and the 6L6WGBs. I'm just thinking some tubes off the top of my head that are similar. Not identical, but close. These transistors are kind of that same idea, I guess you could say. So anyways, all swapped out, all set to go. Amp is all together. I haven't biased it yet since I replaced the transistors, but we're just going to hook it up and see if it works. I'm going to check the output, see how much DC balance problem we have right now, you know, with the offset not being adjusted or anything with these new transistors. We're just going to check it out. So let's get hooked up and take a look. All right, right out of the box with no alignment, no adjustment, nothing. There's your DC offset for your 2 channels. 27 millivolts, which is not bad for the 1 channel. It still hasn't been even adjusted yet. And only about 7 or 8 millivolts on the other channel. The other thing is driving this thing to check power. Let me get over to that. Okay, we'll run this now up until it just gets up towards clipping. Right about there. And we look up at the power. 26 volts, roughly. That's RMS. So let's do the math. .5 watts. This thing's putting out 84 watts per channel, and it's only rated as a 65 watt amp. That is really good. This is a very conservatively rated amplifier. Let's turn on some THD and see what kind of THD we're getting on the 1 channel. And again, I haven't even done the bias yet, but the bias is really mainly just going to control crossover distortion maybe, and idle current, things like that. But let's check it out. So there's full power, and that's 80 watt full power, not 65 watt. And look at our THD, 0.07, without even being adjusted or anything yet. That's amazing. And if you turn it down to, if we go down to like 50 watts per channel, it'll settle down. It's just, it hangs right in there. 0.05, 0.06. Not bad. I would say that's a pretty good performing amplifier. And we haven't even done any alignment yet. I have a feeling it's going to be really, really close, to be honest. So there you go. Everything's running cool. I mean, these heat sinks they're not even warm to the touch. I think this is going to turn out to be a very good performing amplifier. So we're almost done. We're just going to do the quick alignment, which is just a couple pots there we adjust, and we should be ready to go. Well, I'm checking the bias on this thing. It's supposed to be 20 millivolts. I've not touched anything, and of course we've replaced the output transistors and recapped it and did all those things to it, and look where it's at. Supposed to be 20 millivolts, and look where it's at, right there. Now it's warming up, so it's probably going to creep up, and I would imagine it'll go up to about 23, which is still well within spec. But we're going to let this warm up for another 10-15 minutes, and then we'll bring it back right on 20. I checked the other channel, by the way. It was a little bit lower. It was probably about 10 or 12 millivolts. Again, none of that would have hurt anything, but we definitely want to get it right on. But yeah, this thing's walking the line. As far as a very strange thing on this, they do not have a DC balancer, an offset adjustment. They're calling it midpoint, is what they call it, mid potential, and really that's your offset. And although they give you a place to check it where you can test it, there's nothing you can do about it if it's out. So if it's a little bit off, it's a little bit off. But really the feedback and everything else in the circuit takes care of that for the most part. And so really you're not going to get, if everything's working properly, you probably should not have much offset that's going to mean anything anyways. So there you have it. There's really not much to show you. I just, you connect your meter down on that one resistor, which they're showing you here on the schematic. If you look, there's the outputs, and you just read across one of these resistors. It doesn't really matter which one. Read across there, and you should see somewhere around 20 milliamps, or millivolts, I'm sorry, 20 millivolts. And if you wanted to do the math, Ohm's law, you could actually calculate how much current that is. If you take the voltage, just take the voltage and divide it by that 0.47 ohms, and that'll give you the actual current. But anyways, I really didn't have to touch it if I didn't want to. It's on there, and you can see, just like I was saying, after sitting here for a while, it's sitting at about 23 right now. And it's going to creep a little more maybe. So like I said, we'll give it 10 minutes, we'll tune it up, and I don't know, put the thing together. It's done. Looks good. All right, we're all back together, and we're running this thing at a nice cool 10 watts per channel. And you can see the sine wave there, and we're running at about 500 hertz right now. And so this thing performs really well, low distortion. Go to square wave, not too bad. Now when you drop down much below this frequency, the square waves get really rampy. So this is not a real solid amp for for square waves, but hey, there not very many amps are really. As you get up to higher frequencies though, it works just fine. So let's see here, if I go to, let's look at 10 kilohertz. And let's open up the scope a little bit. Not that much. There we go. And you can see it's not too bad right now. And if we go to sine wave, not bad. So there's 10 kilohertz. Let's look at 20 kilohertz. And there's 20 kilohertz. As you can see, rock solid, no distortion, looking good. And even it's supposed to go up, I think, close to 40 kilohertz. There's 40 kilohertz. So for high frequencies, this is the amp for you. It really performs very well at high frequencies. Now again, with the low frequencies, we can go down to 20 hertz. And of course on a sine wave, it'll do just fine. Of course our scope needs to be adjusted a little bit. And you can see, looks beautiful. That's 20. And if we go down to, let's try 10. And there we go. The refresh rate on this scope is really kind of lousy. A lot of you have asked what kind of scope this is that I'm doing this on. And it is a Handtech Model 6000. And all it is if we zoom in, it's just this little unit right down here. It's just this little, it's just a USB based 4-channel 100 megahertz oscilloscope. I think it's actually a 200 megahertz oscilloscope. But as you can see, first of all, when you use a computer monitor, the display is not real high resolution compared to like a digital phosphor oscilloscope. The inputs are noisy. They can pick up noise very easily. So this is a very low cost scope you can buy on Amazon or eBay or whatever. And you know, you're talking $100 or something for a 200 megahertz scope. It is what it is. It will pick up high frequencies, but it's not something I would use for RF. It's really good for making videos because I can do full screen mode, and it's really easy for the camera to pick up, as you can see. But when you see little things on this scope, like how it kind of flat tops here, that's really not a flat top. That's not really distortion. It's just the resolution of that trace on the software. So you know, it's okay for this, but it's definitely not a high precision piece of test equipment. It's good for looking at power supplies, low frequency things like the dummy load and things like that. And that's what I use it for. So anyways, let's hook up a music player and maybe we'll listen to something and see what it sounds like. Okay, so I have this, I'm on the microphone in the camera now. I have the shotgun mic disconnected, and I kind of set the recording level, hopefully that it'll pick this up properly. And I can tell you, I really love this loudness knob here. This thing here, how it works, is really cool. So let's start this up, and I'll let you hear what it sounds like. Now let's turn the loudness knob down. You can hear that's flat. right there. As you turn it down, it actually turns the loudness contour up. So listen to, again, we're on no loudness. Pretty cool, huh? I really like this amp. I really do. I've never heard a CA-810. I've heard some of the natural sound receivers from this generation a long time ago. There was a high-end stereo shop out at a university, a college that I was at, and actually it was called Tony's Audio, but and some of the amps sound really awesome, but this, with this loudness, it's like having another whole tone control. It's very cool. So this is a great little amplifier. I think the owner's going to love it. I know that if he doesn't like it, I'll be happy to take it off of his hands, but I doubt that he'll ever want to part with it once he hears it. So yeah, we found the one knob here that was missing. It was actually under the flap of the box and kind of wedged underneath. It came off. So we have that one back. So really all we need is a volume knob. I looked online and there are quite a few on eBay, but if any of you know any other sources, just let us know in the comments section. But until then, there is the matching tuner that goes with this. I'm going to fix that up. I don't know if it's going to make the cut for a video or not, but definitely a nice little amplifier. So with that said, that wraps up another restoration here, and lots of more videos to come, and working on a rather complicated video. I'm going to redo the CT video, how a CAT scanner works. Hopefully I can get enough footage together to get that put together and get it out. But and lots of audio gear, tons of different audio gear coming. All right, everybody, have a great day, and I appreciate all of you and all of your good comments and everything, and I'm sure we'll keep the videos coming. So until then, have a great day and stay well. Take care. Bye-bye.